Logarithmic equations, question 21. Solve for x. Now here, log of x minus 3 plus log x minus 4 minus log x plus 5 equals to 0. Now as you can see, they all have the same base, and the base is 10. Now we can always apply the product and the quotient rule for the log. The product rule says that this can be combined as written in one log, like product of this divided by x plus 5, because that is with minus. So we can rewrite this as log of, let me put it, x minus 3 times x minus 4 divided by x plus 5, and everything equals to 0. Now as far as 0 is concerned, the only value which gives you 0 is actually log of 1, correct? You can do like that also. You can say, well, log of 1 equals to 0, right? And that is why this should be equals to log of 1. That is one way of doing it. Second is, what we can also write this as, we can write this as, this is to the base 10. So we can write from here x minus 3 over x minus 4 divided by x plus 5 is equals to 10 to the power of 0. This 10 is the base, correct? 10 to the power of 0. So that is another way, and that is also 1, right? And anything to the power of 0 is 1. So we can write this 10 to the power of 0, which is equals to 1. So both are the same things, correct? So either way, you get the same result, right? Now is to solve this kind of an equation. So we can cross multiply and solve for x, correct? So let's do it. We have x minus 3 times x minus 4 is equals to, we'll take this on the other side, and we get x plus 5. So we're trying to solve this rational equation, x minus 3 times x minus 4 divided by x plus 5 equals to 1, correct? So we cross multiply and we get that. So it's basically a quadratic equation. We'll expand this and we get x times x is x squared, then minus 4x and minus 3x, and that gives me plus 12 equals to x plus 5. Now we can bring the terms together, right, and combine them. So we get x squared minus, let me add the steps, it doesn't matter. I'll bring this x combined with these x's, and then I have 12 and then minus 5 equals to 0, correct? And let's combine all these terms and we get x squared. This is minus 8x, and that one is 12 minus 5 is plus 7 equals to 0, correct? Now this could be factored and we can write this as, so we need product at 7, right? And the sum of the two numbers should be minus 8. So those two numbers could be minus 7 and minus 1. So when you do minus 7 times minus 1, you get 7, and their sum is minus 8. So we can factor this as x minus 7 times x minus 1 equals to 0, correct? And that leads to two solutions. One solution is x minus 7 equals to 0, and the other is x minus 1 equals to 0, correct? So we have two solutions, and one of them is x equals to 7, the other one is x equals to 1. So we have two solutions for this equation. Now it's a good idea to check whether they lead to the right result or not, correct? Now what we can do is we can plug in 7 here and see in our equation, and we can also plug in 1 and then check, correct? Now if I do 7, then what do I get? I get log of 7 minus 3 is 4, correct? And then I get log of, I could have actually placed them here, right? That is a better idea. Let me put them here, and then we can say, well, log of 7 minus 3 is 4, and then 7 minus 3 is 4 is 3, divided by 7 plus 4 is 12, right? So that is what we get, which clearly is 0, right? 12 divided by 12 is 1, and we get the right answer. So that is perfect. Now, why I'm not checking from here, I'll give you a reason just now. Now, here it is log of, if I plug in 1 here, correct, then what do I get? 1 minus 3, it actually gives me minus 2, right? And here it gives me minus 3, right? And here if I plug in 1, it gives me 6. Now, as per the mathematics goes, this gives you the right answer, and that's the reason why we got this, correct? But truly speaking, in the log sense, this is not right, since it does not fall in the domain of the function, correct? Domain, why? If I plug in 1 here, then you get log of minus 2. Now, log is only valid when the argument is more than 0. It's not valid for minus 2. Therefore, 1 actually does not lie in the domain, so it is not valid. Not valid solution, right? That is why only one solution we have for this equation, and that is x equals to 7. So we have a solution here, and the solution is x equals to 7, right? Now, these kinds of questions, we should always check our domain also, right? So let me write down the domain here for the function, right? So domain should be, when we check this function, it should be greater than 3, and this says greater than 4, and this says greater than minus 5. So greater than 3 or greater than 4, so we have, let me write all the possible domains which we have. This one is x should be greater than 3, and then we have x should be greater than 4, and for this we have x should be greater than minus 5, correct? So now, if x is greater than minus 5, well, then it will fail these two, correct? So the valid, when we combine all, we say intersection of these is x greater than 4. So that is our ultimate domain, x greater than 4. Do you understand? So the domain of this function is, let me write here, domain dx is x belongs to real numbers where x is greater than 4. Now, we can also argue here that since x equals to 1 is not in the domain of the function, it is not a valid solution, and the only solution we have is x equals to 7, and so that is our answer. Perfect? So these are different ways of looking into it. At times, you will also see logarithmic equations where the question will be check for domain and then solve for x, right? But most of the time, it is just solve for x. It is up to you to check for domain, right? And write down the valid answers. So if you write both the answers, your answer will be wrong. Okay, so be careful and take care about it. Thank you.